Well, in the previous videos, we did question 1.1 through question 1.5. I mean, question 1.4. Now we're going to do question 1.5. The question says that given r of x equal to the square root of 3x minus 5 all over x minus 3. Now, let's say for which value of x will this expression root of 3x minus 5 over x minus 3 be real? So I'm gonna write a question here. We have like question 1.5 is given that square root of 3x minus 5 all over x minus 3. Now we want now we can just working question 1.5.1. We want the values of x for which the expression is real. Okay. This expression will be real. Okay, I'm gonna write it here. Now we're solving the problem. We have like root of 3x minus 5 all over x minus 3. Well, this will be real if under two conditions. If the value inside the root is 3x minus 5 is greater or equal to 0. Okay, so because the square root cannot accept is invalid for negative values, it must be 0 or more. So now, if it is greater or equal to 0, then what we can do, we can find out the value of x. So that means 3x will be greater or equal to 5, and then we can divide both sides by 3. We divide by 3, we divide by 3, and then we get x is greater or equal to 5 over 3. So it is going to be real if x is equal to greater or equal to 5 over 3. Now, the other condition is that if you look at the denominator, you know that the function, a number is, or a function is undefined when the denominator is 0, okay? Because division by 0 is ruled out. So another condition will be that x minus 3 cannot be equal to 0. So this means that x must be different than 3. So the conditions are x must be greater or equal to 5 over 3, and also different than 3. It can be written like this. Sometimes we can write the two like x is element of okay, all right, can be written like greater or equal to 5 over 3 minus this element 3. It can also be written like that. So you can write like this and that, or write like this. See, correct. Now, question 5, 1.5.2 says, for which value of x will the function t of x equal to 1? Okay. Now I'm gonna move my board here. We're working now 1.5.2. So we're looking for the values of x for which the expression t of x equal to 1. Now t of x is given by root of 3x minus 5 over x minus 3. And now we want the question implies that we set the equation equal to 1. Now we can just by cross multiplication, because 1 is like 1 over 1. So if you cross multiply, we take this numerator times by 1, and then we can also take this denominator times by 1 there. And then this will be square root of 3x minus 5 times 1 equal to x minus 3 times 1, which is just a square root of 3x minus 5 equal to x minus 3. Now, if I need to solve this, we're going to set these two sides of the equation to the power of 2, because the power of 2 will cancel the square roots, okay? And then we will be left with 3x minus 5 equal to x minus 3 times x minus 3. And then this makes what? X squared minus 3x plus 9. So x times x times 3x, x times x squared, x times 3. 3x, negative 3 times x, negative 3 times 3, that makes positive 9. So over here, we're like 3x minus 5. Now we can move the left-hand side to the right-hand side. So we have like 0 over here. That's x squared minus 3x plus 9, and then minus 3x plus 5. Now this we can just write, we can underline like terms. X squared is only 1 in terms of x squared. I think I need to move it a little bit this way. So let's split this. So we have like so we can write x squared because only one term that ends with x squared, and the term that ends with x, they are like negative, the form negative 9x, and then 9 and 5 makes positive 14, and that's equal to 0. Now this is a quadratic equation. To solve this, we're going to consider the last term, which is 14, and then we're going to list all the factors of 14. I'll do it here. The factors of 14 are 1 and 14, 2 and 7. That's all. Now, in the list of the factors of 14, there must be one couple which will make a sum equal to the coefficient of the middle term, the negative 9 here. So if we look at with 1 and 14, we cannot make negative 9, but with 2 and 7, yes, we can if we have negative 2 and negative 7. Now, the fact that the coefficient of x squared just 1, we can write x in the bracket like this, equal to 0. Now we write in the factors of 14. They're like negative 2 and negative 7. This means according to the multiplication property, we're going to set x minus 2 equal to 0 or x minus 7 equal to 0. That means x is equal to 2 or x is equal to 7. Now, whenever we do these calculations, we can also check to see which one will make this expression valid. Okay, we're going to check the expression, this expression here. Now, which value of x will make the expression valid? Now, let's check. I'm right here. Check. Now, we have like roots of 3x minus 5, okay, over x minus 3 equal to 1. Is that equal to 1? If I sub in the value of 2, for instance, for x, let's see, is that going to be equal to 1? If you work it out, that makes 6 minus 5, which is 1, square root of 1 is 1, and then over, so over here, we have like 1 over negative 1. Now, is 1 over negative 1 equal to 1? Let's see. 1 over negative 1 is negative 1. And this tells me that negative 1 is equal to 1, which is a false statement. So this is a false statement. So 2 is not applicable. This is not the correct answer. But now, if we check with 7, we have like 3x minus 5 over x minus 3 equal to 1. No, we're checking, okay? On a sum in the values of x, which is 7 there. 3 times 7 is 21. 21 minus 5 is 16. So we have like 16 over 7 minus 4 is 4. Excuse me, 7 minus 3 is 4. It's 4. And then we're checking if this is equal to 1. And then 16 is 4. 4 over 4. Yes, 4 over 4 is 1. So x is equal to 7 is the valid answer that the expression generates. Thank you.